Hi, my name is Xander. I'm in ECE 102 with Rashad, and this is my Lab 5 submission. My lab is Monday from 6 to 6:45 p.m. Okay, just uploaded to my board. This is the high-level Bach diagram of my ALU circuit. And this is my board here. So switch 0 is A0, switch 1 is A1, switch 2 is A2, switch 3 is A3. Switch 4 is B0, switch 5 is B1, switch 6 is B2, and switch 7 is B3. Switch 8 is for multiply or add or subtract when it's 0, multiply when it's 1, add or subtract. And then switch 9 is when add or subtract is equal to 1, add equals 0, and subtract equals 1. Okay, for my outputs, LED 0 is output bit 0, LED 1 is output bit 1, and so on and so forth until LED 7 is the last output bit for 8 bits. LED 8 is not being used, and then LED 9 is being used for the overflow bit for the adder or subtractor. So if there's overflow on the addition operation, it will illuminate LED 9. Okay, now for my test cases that I included on my lab submission. So for the first test case, switch 9 is equal to 0, but switch 8 is equal to 1 because we're adding. So now we'll add 0001 with 0001, and the result is binary 2. Now we're going to keep the same A and B, but we're going to switch 9 to 1 because that will flip it to subtraction. Now when I flip switch 9, we get an output of 0 across the board, which is correct because 1 minus 1 is equal to 0. Now we're going to do a multiplication. So we're going to flip switch 8 and switch 9 equal to 0. And our A is going to be 0011, so we'll flip those bits. Still showing 0 because we're multiplying by 0 at this point. Now we're going to flip B0 and B1 equal to 0, and we get an output of 1001, which is decimal 9, and our inputs are 3 and 3, which is correct because 3 times 3 is equal to 9. Now we're going to keep multiplying, but instead of having B equal to 0011, it'll be equal to 0001. So I'm going to flip this bit, and now we're doing 3 times 1, which is 3. Okay, next, turn everything off. Next, we're going to have switch 9, we're going to add. So switch 9 is equal to 0, but switch 8 will be equal to 1 because we're adding. And then A will be 1000, and B will also be 1000. And in this case, I'm using the LED 9 as my overflow bit, which is correct because the addition of binary 8 and binary 8 is greater than 4 bits, so there should be overflow there, which is correct. Now, for our last case, we're going to keep A and B equal to the same, but we're going to flip switch 9 equal to 1 because we're subtracting. Now 9 minus 9, or 8 minus 8, excuse me, is equal to 1, which is correct. Okay, now to show the 4 demo cases required for submission for this lab. So the first multiplication demo is all zeros times 0001, which is decimal 0 times decimal 1, which is 0. And none of the LEDs are illuminated here, which is correct. Next, we're going to go to 0001 times 0011, which is decimal 1 times decimal 3, which should be 3, which is shown here because the first 2 LEDs are illuminated. The next one is going to be 0010 times 0010, which is 2 times 2, which should equal 4. And that's correct because the third binary LED, the third bit is lit up, which is binary 4. Next, the last decimal or multiplication is 0101 times 0011, which is decimal 5 times decimal 3, which should equal decimal 15, and that's correct here because 8 plus 4 plus 2 plus 1 is equal to 15.